Alright, so before we go over our warm-up here on the SOL packet, again, what we gave to you guys is a released SOL. So this is an example of one that they have done in years past. This is a great thing for practice. If you are looking for more practice to do to prepare for this SOL, you can definitely work on this. There are some other ones that they have also released that I can get you a copy of if you would like that as well. Just a reminder, if you are planning to correct and retake the Unit 11A test, that needs to be done by next Thursday. Remember, today is a Thursday late bus day, so if you need to work on corrections, I'd recommend you stay today for that.
Yeah.
You have the opportunity to retake, so that is where extra credits come from. Alright, so then the 40-question JLab that is due next class. Again, that goes as a test grade for 4th quarter. I'm very concerned about the extreme lack of completion of JLabs, and if you do not do that, then that's going to be a 0 for your test grade. We have a lot of zeros right now because we're not turning stuff in, so make sure you get that in. Again, you can retake that multiple times, just submit to us the highest grade.
If we retake the test, we actually retake it.
Yes. Reminders are great. Joe, did you have a question?
That was the question.
How do you do a reminder?
That's why there's alarms right there, right? Oh, you know, alarm. So,
Like put it on the calendar? I've had students in years past totally do alarms on their phone on Sunday nights or the night before. They would put an alarm, do your JLab, so they wouldn't forget. So you're good at programming? Okay, so you were supposed to do questions 11, 14, 15, 16, and 17. So let me get to that. Alright, 11. Which graph best represents the equation 4x plus 5y equals negative 20? So this is a review from a couple of days ago. Remember, we need to get in the form y equals mx plus b. So I need to first subtract my 4x from both sides. And can I combine negative 20 and negative 4x? Can I combine those things? No, why not? What was it? The variables, they're not like terms. They don't both have an x, so we cannot combine them together. So negative 4x minus 20. And Joe, what's my last step here?
Divide 5.
Sorry.
No, you're fine. I'm trying to get y by itself, so what's my last
Divide
step
5.
here?
I was gonna say that.
Thank you. Divide by 5. So I have y equals negative 4/5 x. And what's negative 25 by 5? Yes.
Oh, negative.
Negative 4. So first, let's figure out which one has a y-intercept of negative 4. Which answer choices? Right, so we're down to these guys. We can immediately eliminate these. And remember, on your SOL, you have the ability, they have like the little red X where you can put that on, we don't want those as an answer choice. Use that. Use that to help you out and eliminate choices.
Yeah.
Alright, and then, is this a positive or negative slope?
Negative.
So which one
down.
gives us the negative slope? Hey. There's your answer choice. Again, you can put this in your calculator for y equals and check to see which graph it matches. You can use your calculator for just about everything. When you're dealing with equations, get y equals, put it in, and graph to see which matches. Alright, questions on this one? Okay, so next we have 14. Alright, number 14. So this is a system. This is what you had a lot of your homework on last night. So system of inequalities. There are a couple different ways I'll show you both here. So system of inequalities. Remember, to solve a system of inequalities, we need to either graph it or we can check the solutions. Alright? Since it gave us a solution, I'm going to first check those to see which one works. So this is my x value, this is my y value. So x is 3, negative 3, y is 1. And we're going to take each of these and put it into our equations. It has to satisfy both equations in order for it to work. Alright? So when I put this in, I have negative 3 plus 1 is less than negative 2. Is that true? What does that give me? What's negative 3 plus 1? Negative 2. And is negative 2 less than negative 2? No, it has to be or equal to, so that does not work. Immediately, we can't do it. It has to be true for both of them. Okay, letter B. Isn't this the exact same thing?
Mm-hmm.
Well, gee, then we can eliminate letter B as well, because it's not, if it didn't work up here, it's not going to work for this guy either. Oh, gee. Alright, so now C and D. Notice that now they have the or equal to. So is it going to work for these ones now? Okay, so now we need to check our second equation. So far I've only substituted one time. So you can, through some thinking and evaluating, you can eliminate some choices. Alright, so let's check this. 2 times negative 3 minus 3
Negative
times
6.
1 is less than negative 9.
Negative 6 minus 3.
So is negative 9 less than negative 9?
No.
No, so this isn't going to work. We
Has
need
to
it to
be.
say or equal to, which this does. So D is our answer.
I think that hurt. Can I go to bed? You say this.
Do minus sign. Pass.
Alright, the other way we can do this, aside from just checking our solutions, is to graph this, okay? So listen up, because, again, this will answer some of your questions from your homework. So to graph this, we can double check to see if we did it correctly. I have x plus y is less than or equal to negative 2. Subtract my x over, and I get y is less than or equal to negative x minus 2. For my second equation, if I subtract my 2x over, I get negative 3y is less than or equal to negative 2x minus 9. Then when we divide by negative 3, I have y is, what do I have to do when I divide by a negative?
Switch them with the sign.
Flip the sign. Good. So y is greater than or equal to, do my little heart here, 2/3 x, right here, plus 3. So when I graph this, let's see, I have a y-intercept of 3, and up 2 over 3, down 2 over 3. So it's going to look, let's see, it's or equal to, so it's going to be a solid line. And is this shaded above or below? Above. Good. It's greater than, so it's shaded above. This direction. And so that was this guy. Now let's do my other equation here. My y-intercept is negative 2. My slope is negative 1, so up 1. And this is also a solid line. And is this shaded above or below? Below. So we have our shaded region where they overlap. That is where our solutions are going to be. Now, if we look at what they asked us, it says, for which system is negative 3, 1 a solution? Well, negative 3, 1 is right here, which lands on our lines. So our answers are in the shaded region, and then if it lands on a solid line, so notice how these are my boundaries here of the shaded region. So my answers are anything in the shaded region, and then if these are solid, those are included as well. If it's dotted out, it does not include those. So here, since it's a solid line, it lands on my boundary, then it is a solution. That's a tricky type of thing I like to do. So again, any solution, just plug it in and check to see which one works. Or you can graph it here and do it that way as well. Also, on your calculator, remember that we can graph these as well and do the shading. So I'm going to pull my calculator and show you for a different one for them. All right, any questions on this one? Okie doke. So let's take a look at number 15 now. Another one. What is a solution to this system of equations? So what was the difference between these type of equations and what we had for 14? What do you notice about the signs particularly? Right. These are inequalities, and even says the word inequality. Whereas these ones are equations. Remember, inequalities you have to shade, so you're going to have a whole bunch of answers. Equations, you don't have to shade, so it's just where they intersect. So again, we can check each point and see which one works, or I can go ahead and find the solution here. And remember, the way to solve a system, we can use substitution. Anyone remember what the other one's called? Linear combination, good, which is also known as elimination. Linear combo. And the last thing you can actually do is also graphing. Again, on your graph, it's where they intersect that is your solution. Okay. So we're going to start off by graphing. Save myself some time. So I'm going to subtract 2x from both sides. Remember, to graph, I need to get it into y equals. And in my calculator, I can graph anything that is in y equals. So I have 4y equals negative 2x plus 22. All right, divide by 4 on both sides. I get y equals, do my heart, it reduces to negative 1/2 x, and that's some beautiful fraction. Okay. Now doing my next equation, subtract 7x, I get y equals negative 7x plus 4. Okay. So go ahead and get out your calculator. Again, we're going to be using the calculators heavily today. So I want everyone to have out their calculator and go to y equals. Sir, do you need a calculator? You do. You need one. So I want everyone to go to y equals and type in those two equations.
Is this press graph?
Yeah. Calculator's kind of in the way here. And again, make sure you hit clear to clear out your equation. Okay, so I have put all fractions in parentheses. Negative 1 divided by 2 times x and plus parentheses 22 divided by 4. Okay, so that's my first equation. My second equation, negative 7x plus 12.
Can you simplify from 2 over 4?
You know,
You simplify from 2.
you can simplify 22 over 4. You can put in the decimal. Either way, it's all the same numerical values. They're equivalent. X plus 1. All right, so do a double check to make sure your equations match up with what you have. And then graph, or if your graph looks funky, remember zoom 6 is your standard. Alright, so the solution is where they intersect. If I look at my graph, what appears to be my solution? What does that intersection point look like?
5, 2, 5.
I think it looks like 1, 2, 3, 4, 5. Okay, so I suspect that it's 1, 5. That's kind of hard to see there. What you can actually do is you can actually even zoom in, get a little bit closer. It'll help you see. Although I think that goes too far off the graph. Sometimes that helps you out. Okay, I'm gonna go back to zoom 6. But it zoomed in too much. It went off the graph. Those of you that are pretty smart or tech savvy with your calculators, mess around with your zoom options. There's a lot of different things you can do. What's really nice is the zoom box, where you can actually draw a box around what you want to zoom. Okay, so anyways, we suspect that our intersection is 1, 5. So go to second graph. That takes you to your table. Notice we have both of our y values listed. Remember, your solution is where they are the same. When you look at your table, where are your y values the same?
1, 5.
Oh, look, 5, 5. That's at the point 1, 5. So we were correct. That solution The intersection point, which we thought was 1, 5, we verify with our table. It is indeed 1, 5. We can see that right here. All right, so our answer choice is C, 1, 5. Again, if you were to take each value, each x and y, and put it into your system, you would find that that works. So you have, let's see, substitution you could have done, elimination you could have done, you could have done graphing, you could have taken the value and just put it into your equation, you could have looked at the table. You have 5 different ways you could have done this problem. So I don't want you to get to this problem on the S1 and be like, yeah, I just don't know how to do it. You have numerous ways you can do this, even if you don't remember how to solve a system. Check each point in your equation to see which one works. All right, I want to show you one more thing with the calculator. This is a really neat trick here. So go back to your graph. And remember, the solution is where your intersection is. So see how the button that says trace above that says calc? That means calculate. I want you to hit second, calculate. And notice that option 5 says intersect. So you want to calculate where they intersect. So we go down to 5, or just hit 5, hit enter. And it's going to ask you a couple questions. It's going to say first curve. So it's going to move the little flashing light to your first line. You just go ahead and hit enter, saying, yes, that is my first curve. That's my first line. Then it's going to say second curve. And you can't see it because it says 0, 12, but you can actually move it down some. And you see it's on your second line. So you say, yes, that is my second line. Hit enter. And then it asks you, do you want me to tell you what the intersection is? And you say, yes, I do want you to tell me what the intersection is. Boom, it just gave us the intersection. So there are 6 ways now as to how you can solve this problem. Again, anytime that you have equations, y equals, get it in the form y equals, and graph it. Okay. Questions on that? Okay. So again, you're not allowed to give up on any questions on the SOL. You have to show that SOL who is boss. All right, next, 16. This is a little bit of a throwback to our last unit. This is the graph of negative x squared minus 2x plus 8 is shown. On the grid, identify each of the solutions. Notice the directions say click on the grid to plot each of the solutions. You must plot all solutions. Now for us, obviously, you're clicking right now. It's a paper copy, so we're just going to plot them. All right, solutions. What is another name for solutions? What's up? Which things? Yes, true answer, but when we're thinking of quadratics, we had 4 words that all mean the same thing. Solutions. Zeros. Good. Roots. And the last one, that's my favorite. X-intercepts. So here when they're asking for your solutions, they are asking for the x-intercepts. Your x-intercept is where it crosses your x-axis. So what are our x-intercepts here? Negative 4 and 2. Boom, done. You just got that question completely right. Now I want to show you something else. This might be a little...
What could be easy?
Oh. It's easy, right? You're just plotting the dots. Now be careful. Check to see what they ask for. If they ask for the solutions, I want only these solutions. Sometimes they'll ask you for the x-intercepts and the y-intercept. In that case, you would need to plot your y-intercept. But the mistake some of you guys were making on your test was that you gave me the y-intercept when I never asked for it. Your solutions are just your x. Okay, I want to show you another trick with your calculator that you can use to help you out with this. So pull out your calculator. And let's type in our equation here of the negative x squared minus 2x plus 8. So y equals, clear. Okay, so we have negative x squared minus 2x plus 8. It is a parabola. Okay, so this matches what we have here. Now, again, we suspect that negative 4 into our answer, so that was pretty obvious. But I want to show you, let's say that they didn't give you the graph. Let's just say they gave you only this equation. And they said, what are your solutions? Something you can do is put it in your calculator, and you can look here to see, okay, it looks like negative 4, it looks like 2. Remember, we go to second table, And we see -4 is a 0. It has a y value of 0. And 2 is a 0. It has a y value of 0. So you can look at the graph and identify it. You can look at the table and identify it. Another way you can do this, remember that calculate button? Hit second, calculate. What is another word for solution?
0.
0. Look, you can find your 0. So go down to option 2 to enter. Now you have to do a little bit of work for this, okay? So it asks you left bound. What it's telling you to do is get close to one of your solutions, one of your x-intercepts. So you hit the left arrow. You keep going left until you cross that x-intercept. It is like a roller coaster. And I'm now on the left side of it. So it says left bound. I get it on the left side of it. You can go anywhere on the left side. You can go further down or closer. It doesn't matter. Once you've gotten it on the left side, hit enter. Now it's going to ask you right bound. So now we arrow to the right. So we go past it. Because again, we know this is our solution here. So we go past it and it's on the right side. Then hit enter. Then your calculator is just like Microsoft Windows where it says, are you sure you want to close this program? It asks you, are you sure you want me to give you your 0? And you say, yes, I do.
Yeah.
And it just gave you your solution, -4, 0. So you can use that as well. That's a third way you can use, a third way you can find your 0. So you can look at the graph and just count it. You can look at the table and see which one's a 0. And you can use the 0 function on your calculator. The reason this is nice is because your table, unless you set it up otherwise, only gives you your integers. So what if my 0 was 2√2? You can't figure that out by just looking at your graph. It would give you the decimal here, and then you can find out which of your answer choices matches that. So that's another method we can use there. Another way, a fourth way, is that anytime we have an expression equal to another expression. Okay, Sean and Joe, are you with me?
Yeah.
Okay. Anytime you have an expression equal to an expression, that is actually just a system of equations. So what you can do is type in the left side, then type in the right side, which is just 0. Graph it, zoom 6. And what it's doing is it's also graphing that y equals 0. And then it's a system of equations. All you have to do is second, calculate, intersection. And you can do that to find each intersection. So that's another way that you can solve this. Anytime you have two expressions equal to each other, you can put them in the left side on top, right side on the bottom, and find what the intersection. Okay. You can also use that when we're solving equations. So let's take a look back at, where was that problem? It was one of these earlier ones. You can use it for this guy. That's not what I was looking for. Nope, not that one. Because there are two variables in that one. Let's find a good one.
16.
Oh, yeah, the next one. Okay. So number 17, our next one that we were going to look at, we can actually do that with. So first of all, let's solve this the normal way. What is my first step going to be? Yeah, we could just check each value and put it in for x, but Trudy, what do you want to do? Subtract 3x, that sounds good to me. So I get -20 equals -5x. Divide by -5. And I get x equals 4, right?
What is that?
So that's our original way to solve. That's one method we can use this. To check our answer, or if you're stuck, you have no idea what to do, we can check each of our answers here. Have we talked about the store button yet in this class?
No.
Oh, wonderful opportunity. Get out your calculator. and let's use the store button. So go to your home screen here. STO. It's right above your on button. That stands for store. Anytime you're checking a solution, evaluating, this is going to be your best friend. Okay? So we suspect that C is my answer. I'm going to check C. So I'm going to check that 4 is my answer. So I want you to type 4, store, right above the on button. And then we have the variable x, so I'm actually going to type in x, 4 stored to x, and then hit enter. Now, anytime you type x on your home screen here, it's going to say 4. Guess what 2x is?
4. 8.
8. So 2 times 4 is 8. So now your calculator knows to take 4 and put it into your equation. Did you figure it out? So type 4, and then STO, the store, x, and then hit enter.
Wait. And then
That's what I have to do so far. Okay? So now we're going to check to see if it works. So what I'm doing is I'm taking 4 and I'm putting this in for x of both sides of my equation. So first let's do my left side. So type into your calculator 3x minus 20. Negative 8. Okay? So we got negative 8 for the left side. If this is true, it should get the same thing for the right side. So negative 2x, negative 8. Since these are equal, it makes the equation true, so this is indeed my answer. So it's a second way of solving it. So again, that's another way to check your answer. This saves you time from having to type in parentheses. This is really great for fractions. Instead of having to type in parentheses, negative 2, 0, parentheses, you just type in x. And you're just typing exactly what you see here. Okay, so that's 2 ways of solving it. So your calculator has always just had a value assigned to it.
Does anyone need help with this guy? Please be careful not to use this willy-nilly. Do practice it, but make sure you know what number is plugged in for that value, because you don't want to plug in 4 and then go on another problem and assume that the next one has the right answer and still has 4.
Yeah, so you need to change your x value for each time that you're using that store function. It'll say 4 until you overwrite it. Now when you graph, your calculator knows that x is just a variable and not a number, so it won't mess up your graph. Okay. Alright, so the other thing we can do is, again, here we have an equation.
Wait, can I do that with any?
Yeah, so you can use this, and we'll do this later today, where you can store in your values for any alpha numeric or any alpha letter on here.
If any of you, while Ms. Margaret is going through this, aren't seeing it or getting behind, please raise your hand so I can go help you. Don't wait until we're done and then go, I have no idea what to do. Okay?
Alright, so again, another way we can do this, we have an expression equal to another expression. So go to y equals, clear out what you have. I'm going to type in the left side of my equation, 3x minus 20. Type in the right side of my equation, negative 2x, and go ahead and hit graph. Now I should expect to see if they intersect where x is 4. Let's see. It looks like it, but again, we can either go to our table and check to see where our y values are the same. And we see they are the same here. Or I can go to my graph again. Oops. And I can go ahead and do intersection. Second, calculate, intersection, enter, 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 and it gives you your answer, x is 4. So that's, I think we're up to 5 different ways you could have solved that problem. So never just skip over a problem in the SL and don't try it at all. You have many, many, many ways you can figure it out. All right, questions on that? Okay. Alright, we're going to go ahead and transition next to notes. I want to make sure we get through
What
that.
about the homework?
We're going to do that at the end.
I mean, my name equal number.
Oh, isn't that nice? Okay, so we have worksheet 8 of the notes for today. We're reviewing exponents and radicals. In our calculator, we're going to use that store button a lot to check our answers. I'm going to show you how you can check it for that too.
Thank you.
You are welcome. You're welcome.
So what did you say about the homework?
Yeah, have them start signing password.
Are we gonna go with that?
We're going to go over the homework after. That's not what I wanted. Hey. Alright, exponents and radicals. So you have at the top of your paper, it's a reminder of exponent rules. So if we are multiplying same base, we add the exponents. If we are dividing the same base, we subtract our exponents. If I have an exponent raised to an exponent, I multiply them. I distribute my exponent in parentheses. Anything to 0 power is 1. And I distribute my exponent to parentheses again over here. Remember, negative exponent, whenever you see a negative exponent, it says, move me, move me, move me. Once you move them, you no longer need the negatives. Alright, let's just go ahead and start knocking out a few of these. Number 1 says, which expression is equivalent to 3x to the negative fourth, the whole thing squared, times 5x to the negative second. Okay, so let's first, actually, what do you guys think we should do first here? Distribute. Good. What are we going to distribute, Trent? Good. I'm going to distribute my exponent here to both the 3 and to the x. So let's see. I'm going to start calling on people. Morgan, what is that going to give me? Sorry, for the 3 first. So 3 squared would give me 3. Squared. 9. Good. And then we multiply our negative 4 and 3, so we have x to the 3 times negative 4. Oh, it's a 2. Sorry, I already lost it. I know, I'm losing. I'm getting old.
I don't know.
Negative 8. Alright, and then we have times still our 5x to the negative 7. Okay, what's my next step? You've got the right idea, but the wrong way of going about it. We're going to add our exponents together. So when I multiply my x's together, I add the exponents, I get negative 10. And what else do I need to do?
Multiply 9 and 5.
Good! Multiply 9 and 5. Thank you, Alma. Well done, Trinity. Alright, so 9 times 5 gives us 45. Alright, so we have 45x and negative 10. But we cannot finish with any negative exponents. It goes underneath. So this guy's screaming at you, move me. So he moves, so I have 45 over x to the 10. Which answer choice is that? C. Alright, so we have done this the normal algebraic way, but let's check our answers. Joe. Come on. Not summertime. You can lounge in the summertime. Alright, so get out your calculator. I'm going to show you a wonderful way to check this. It involves using that store button. Okay, we don't have a value for x, right? It's just x.
4.
So we get to make it up. Alright? I always start with 2, and then if I have another letter, I use 3. If I have another letter, I use 4. Don't use 1, don't use 0. Okay? So I'm going to, since we only have an x, I'm just going to use 2. So I'm going to say x equals 2. Okay? So in our calculator, 2 store to x. and enter. So now x represents 2. Okay. So now let's first do our original expression here. So parentheses 3 x to the -4th. Now, I do want to alert you guys to something. The way that Herndon does SOLs is that you have to use the calculator provided to you. You do not bring your own. Am I correct in understanding that, Michelle? Right. So, in order to make sure no one's cheating and storing answers on their calculator or whatever, they provide it with you where they clear out the memory every single time. With that being said, you don't know if you're going to get one of these guys or one of these guys. And so, depending on which one you have, you might run into the issue, such as I have here, where when you do the exponent, it automatically moves it up for you. Which is nice, but then if I keep typing, and I try to type in
All you have to do is press the down arrow.
squared, parentheses, and keep typing, then I get a million things up there. So if this happens to you, delete it out. Delete what you don't want. Oh. That's my choice. Alright, so -4. And then arrow to the right, that gets you out of it. Okay, so I just want to say that for those that are not familiar with that, because this is my calculator didn't have that, still doesn't have that. So make sure you arrow out of it. So before you hit enter, just make sure it looks right. If you have a whole bunch of stuff in the exponent, it's only problem. Alright, so then we have parentheses 3x to the -4th squared. And then parentheses 5 times x to the -2nd. And again, get out of there and do your parentheses.
5 times x to the -2nd.
So again, I'm just typing it in exactly as I see it. Okay, Sean, I want you typing this in, and Joe, I want you typing this in. Everyone else is doing a wonderful job. Alright. Hit enter. Ooh, semi-decimal, right? Which is perfectly fine. We're just checking to see which ones are equivalent. So write this down. So this thing equaled 0.0439. Okay? So if you get to this problem, you are stuck here. You are stuck, you have absolutely no idea what to do, you can do this method, where we take our original and then compare it to each of our answer choices. Though we did have an idea of how to do this, and we think our answer's C, but we want to double check. And remember, you have essentially a limited time. You have the whole day to take your test. It starts in the morning, so take your time. You have until 4:30, so you should finish. If you don't finish, that means you didn't know the information. You have the whole day. Alright, so I believe C is my answer choice, so I'm going to check that. 45 divided by x to the 10th. Oh, look. Does it match? It matches perfectly, so I know I did it correctly. Now you'll notice if I type in one of my answer choices, such as D, where it's 45x to the 14th, it's not the same, so I know that it's not the correct answer. Okay? So you can use it as a method check. Alright, questions on that? So hit second quit. Okay. So again, that store button is a huge help. Alright, let's take a look at, let's do number, this guy. Alright, let's first do it the actual way. When I am dividing, I need to simplify each piece. So let's first take a look at my numbers. -12 and 6, what does that reduce down to? Good. -2 on top. Next I have a cube. When it's a negative exponent. So Trey just asked a good question. Negative exponents move. Negative numbers are a fact. Alright, a cubed over a. A is a second, good, and that's a positive second, so it stays on top. And last, but certainly not least, our b's. Oh. squared over b squared,
Cancels out.
what does it reduce down to?
1.
1. So they essentially reduce to just 1, but 1 times that is just so we don't need it. So we don't have anything left in our denominator. So this is your answer choice. Which one is that? B?
B.
Awesome.
Instead of dot not once you realize stuff for -2.
That is true. That is true. And that's another good thing to do. You can eliminate answer choices as you go. So as Joe said, -12 divided by 6. We're pretty positive that's -2. And B was our only answer choice, -2. Alright. Now I want to show you, I'm not going to make you go through the whole store thing for this, but I want to show you that you can use it even for this guy. So again, get out your calculator. Now notice here we have more than one variable. We have A and we have B. So we need to use both letters. So I'm going to go ahead and let A equal 2 and B equal 3. I'm about to show you. You could just use X if you want, but I like to go and use the letters that they give you.
By the way, I am listening to see who's participating in the Orchid Candy at the end of class.
Which problem are we on?
Alright, so 2, I'm going to store. Now, if you haven't already noticed, you have the entire alphabet on your calculator. It's alpha, it's in green.
Ma'am,
Yeah.
which problem are we on?
Not number 2, but the one to the right. We're checking to make sure our answer is correct.
Number 3? Oh, I thought that was
I know, we're checking now. Okay, so -2 stored to A. So alpha A. Then hit enter. And we're going to store 3 to B. So 3 store alpha B. Hit enter. Alright, so now let me type in my original and type in my supposed answer. So parentheses, -12 alpha A cubed, make sure you get out of there, alpha B squared, parentheses. That's my top.
If there is anyone who does not
How did you do
here,
the cube
please raise your hand so I can come around and show it to you.
Exponent, the caret, and then 3. So you'll see there's like caret 3.
There is also it under math, English math.
And then divide, parentheses, because you need to put the entire numerator in parentheses and the entire denominator. Parentheses 6, alpha A, alpha B, squared. And we're going to close our parentheses. Do a real quick check to make sure it matches. We had some students in first period where they were doing A squared, B squared, unless they were getting the wrong answer. Alright, hit enter. We get a value of -8. So let's check to see if our answer is negative. Isn't that a popular answer today? -2 alpha A squared. Huh, -8. We did it right. So that is indeed my answer. So I want you to know you can use this not just for the letter X, but for the entire alphabet. Okay? Alright. Let's do...
Would you number... Did you number 8?
Yeah, I'm thinking 3, the one next to it.
Mm-hmm.
Let's do this one.
That's what I'm saying. Yeah, me too, guys. What?
Alright, which is equivalent to this? Now, I like to simplify what's inside parentheses first, and then distribute my negative from there. Can I simplify my x and y any more than it already is? No. So let's distribute that -3. We shall. So x to the 5th, y squared, z to the 8th, over x to the -3rd, y to the -3rd. So I distribute it to each one. Thank you. Okay, now I can simplify each of my letters. So let's do my x's first. 5
2.
minus a -3.
Plus.
So good.
Negative.
Plus. And if you need help with that, In your calculator, if you know that you struggle when it comes to negatives, type it in your calculator. 5 minus a
You
negative
didn't put the
3.
minus.
Oh, I didn't put my minus. Thank you.
My bad.
So 5 minus a negative 3. You know you mess up with negatives. Use your calculator to help you check.
5. 8.
Oh, see? We should double check because minus a negative
Son,
becomes plus a positive.
The sun.
So I get x to the 8th. It's a positive, so it stays on top.
Think about it that way. The bottom has x to the negative 3. That means in order to make it positive, you move it to the top, so you're adding your x.
Yeah.
Alright, next let's do our y's. 2 minus negative 3 gives you a positive 5. That means my y's going to stay on top with the positive 5.
The Z stays on.
And z stays on top with the positive
There's
8.
D.
There's nothing left in the denominator, so which one is it?
D.
You gotta agree.
Just kidding.
Now, as Miss Charlotte was saying, the other way you could do this is go ahead and move your negatives. So then we would have had, instead
So it
of
makes
this,
it positive.
so we would have had x to the 3rd, x to the 5th. Move your y, so y to the 3rd, y squared, and z to the 8th. Then these combine to give you x to the 8th. These combine to give you y to the 5th. And then we have z to the 8th. Again, you can check this with your calculator. Now, I want you to make sure you understand that this variable x here is not the same as your alpha x. So if you store to alpha x, make sure you use alpha x. If you store to the variable x, make sure you use the variable x. Alright, let's flip it over to the back.
Just write that on this.
Probably.
Whoa, you're cool.
Alright, radicals. Make everything a decimal and find the numbers that are equal. So that's one way we can do it. If you have more than one answer that matches, just choose the one with the smallest number of the radicals. So again, I'm going to teach you a few different ways you can solve these.
Number we done?
We're going to start with number 4. Alright, what is square root of 18 written in simplest radical form? Can 2 go into it?
Yes.
Yeah. 9. What goes into 9?
3.
3.
We do like
3 goes into 3 one time. Got her. Alright, it's a square root, so we have to have groups of
2.
2. There's a group of 2.
Oh, wow.
So that's going to come in front. Can anything else come in
Oh,
front?
come on.
Nope. So we have to put everything else that's left underneath. So 2 times 1 is just 2. Remember, we're breaking it up with division. We put it back together with multiplication. So I'm multiplying 3 times negative. Or sorry, 3 times square root of 2. What's your answer choice is that?
B.
Good. Now what's nice with these is these are just numbers. So again, use your calculator, double check, but we don't have to worry about storing. All I do is second square root of 18. And then I think my answer is B, so 3 times second square root of 2. And they're the exact same. So I know that I have the correct answer here. Okay. Now, again, if you are stuck,
This kid gets so mad.
should have blocked it.
Oh.
Boom! Alright. So if you're stuck, you have absolutely no idea what to do, you can just check each answer and see which one has the decimal that matters.
Need like another JLab sheet.
Need another? I've got extras. Alright, so let's take a look at the one next to it. I want to use that method. Again, this is a way to check it, and this is a way to start if you have no idea what to do. Okay?
5 by 2.
Yes, but I'm going to show you a different way first. Alright, so let's first type the square root of 108 into our calculator. Second, square root 108. And let's write down that decimal. 10.392. Okay? Again, this is what you'll do if
Where
you
you
have
guys
no
at?
idea what to do.
Where you got
Trick.
Yes, ma'am.
Focus.
I'm here.
Alright, type in each of your answer choices. I want you guys to do this. Type in each answer choice and write down the decimal that you get. Thank you for your participation.
Chicken Dolly Tree? What are we?
Shut up.
It's A.
Yes, ma'am.
Uh,
The answer choices.
what do you mean the answer?
So gross. No.
Alright, what do we get for 2 root 27? What was our decimal?
The same.
Oh, was it?
Yes.
10.392. Joe? Alright. What do we get for our decimal for B?
I got the same.
You got the same? 10.392. Did others get the same?
Yes.
Yes.
Alright, what do we get for C? What was our decimal?
The same.
Same thing.
The same? Oh boy. What do we get for D?
31.17.
Ah, so at least we can eliminate one.
I mean on there.
You're gonna get this. Okay. So our answer choice has to be exact same decimal, so we can eliminate D. Now, it has to be completely simplified. Can I break down 27 even more? 27 divided by 2? It divides by 3, right? And then divides by 3 again. That's why we cannot choose this, because it's not simplified completely. It's the same, but it's not in simplest radical
The
form.
only one I did was C.
Good
And
job.
12 we can also break down.
Hey, what?
So C is our answer here.
Shut her in.
Now, if you're not sure if you can break it down, what you want to look for is the answer choice that has the smallest number under your radical. If you notice, 3 is the smallest number under your radical.
But also for 18, 3 is also simplified.
Yeah, so this one, 3 is the smallest one, but it's not the same numerical value. So you could actually start off by going to your smallest ones and then just checking those answers.
Are you students now?
Hold your horses. All right. To do this for real though, we would break down 108. What can we reduce that by, or what goes into it? 2, which gives me 54. Oh, I better write this down. All right. What can we do with 54?
2, which is
2.
26. 87.
27. What can we do with 27? 3, which is 9, and then 3, which is 3, and then 3, which is 1. So remember, if we break it up by division, we put it back together with multiplication. So,
Groups of
darling, what is a group of 2 that we have? Good, we have a group of 2s. All right, I'm going to throw it. Sorry guys, I don't throw well and I don't catch well, so bear with me. Don't. All right. Kadra, what's another group that we have?
3.
Good, a group of 3s. Hey, no laughing.
Yeah. No,
You better be ready.
She'll miss.
All right. Watch out on that. My instead. All right, so these both come out. So it's 2 times 3 that comes out. Can I take anything else out?
No.
All right. So Sabrin, what is left inside? Yeah, there's 3 times the 1, which is just 3. All right, Sabrin, watch out. I'm not that bad. Look, she just did that so nonchalantly. Well done. I'm impressed. This is me. I'm like. All right. So 2 times 3 gives us the 6 root 3, and that is our answer.
Oh.
So that's the actual way to do it. Oh, check out. Better watch out. It's gonna be coming. All right. So I want you to now try. Let's do this one. I want you to try these two guys here.
Dude, it's empty.
Dude, you should be working on these problems.
Dude, sorry.
Okay.
Yeah.
Look at my page.
Thank you for asking.
Oh,
So we should be working on these two now. Makes me miss that. The two letters start.
You already did it.
I don't think we did it yet.
The 108 was for the one above it.
Caitlin Rice, I did.
No. Close your eyes. I'm doing it right now.
Calm down. Hazel. Think that's funny?
Yes, I do.
Guys, do these problems.
We got it.
All right, how are we doing? Do we need 1 more minute? 30 more seconds?
1 more
I'm
minute.
almost done. Hold on.
1 more minute? What? What'd you say? Sorry. What? ¿Qué pasa?
You want to go to lunch?
Hey, check.
Yes, sir.
Okay.
Okay. Please stop. Ew. It's gross. Stop, man. It's gross.
You're gross.
You did it.
Here,
Ate them up.
So, I was like, oh, this is a taper face.
That's it.
I was like, cover the ears. Was it cover the ears?
So that's the idea you want to do.
No muscles.
All right, what did we get for the square root of 180? C.
340.
Thank you.
I know.
Another one's coming your way. All right.
A.
All right. What do we get for this guy?
A.
A? Do we agree?
What if I said it's not gonna candy?
I'm not giving
Wait, can I switch? I don't want your.
Alright, you should be like, oh!
You can give it to me.
Alright, so I want to take a look at how to actually. I want to take a look at how to actually do this one by hand. So 48. What can we break 48 down with? 2. Which gives me.
3, 4.
And we break that down with.
2.
Which gives me. And break that down with. Which gives me.
6.
Break that down with.
2.
Which gives me.
3.
And break that down with 3, which gives me 1. Okay, we have to have groups of what here?
3.
3. So Muhammad, what is a group of 3 that can have?
2.
You see it, you should have said the name.
I did.
I thought you were talking about Ali.
Thank you, Muhammad. Now, Muhammad, is there another group of 3 that I can take out? No. There's not another group of 3. You ready?
No.
Alright, there's not another group of 3, so only my 2 comes out in front. And I still have 2 and 3 left underneath. Abdul, do you remember what I have to do with that 2 and 3?
Multiply
They're
it.
both underneath.
Multiply it.
What is my operation here? Do I add, subtract, multiply, or divide? Multiply. Good. So what would that give me underneath? What's 2 times 3? Good.
Okay.
Ready?
Yeah, I'll do it. Okay. Coach Bradley said he did not pay.
No more candy for you. You're done. That was so mean. I could tell by the way you went.
Look.
Remember, watch out. Alright, so we have 2 root 6. Cube root. Careful, they might do that where they throw you a square root rather than a cube root. Alright, let's take a look at 7 and 8. These ones have letters now. Alright, so Tayshawn. What type of root is this? How many of a kind do we have to take out? Yeah. So is it square root, cube root, fourth root, fifth root?
Cube.
7.
9. Cube. Cube.
Is there a little 3 in front of it?
No.
This is a cube root. This is a square root. So when we break down our 42 and we break down our n, then we need groups of how many? 2. It is a
3.
square root groups of 2. Groups of
2.
9? Alright, Tayshawn, what can I break 42 down with? What's a number that goes into it? 2? Good. So we have 2 and that gives us 21. Morgan, what can I break 21 down with? 3.
7.
7.
I told you.
What?
7. You looked at me like I was stupid.
I didn't even look at you. Alright. G. Is there a group of 2 anywhere in there? Oh, so what does that mean for me?
Golly.
Leave it.
So what does that mean if it can't break down into any groups of 2? You leave the whole thing inside. So Alex Tercios, which answers can I eliminate? Which ones can I already eliminate? Alex Tercios. Thank you. Yeah, whatever. You were like 5 feet away from it. Your arm span isn't that long.
Yeah.
Still would have made it. Alright, so we can eliminate these guys. Now let's take a look at the n. So we have
You can just do 9 divided by 52.
1, 2, 3, 4, 5, 6, 7, 8, 9. How many groups of 2 do I have? 4 groups of 2, so an n to the 4th comes out in front, and there's still an n left underneath. These are answers. Guess what? We can use the store function for this guy as well. You can store it in for n, or instead you can just use x. This is also great for especially number 8. Use the store function here because it asks identify each expression that is equivalent. A lot of times there's more than one answer. So you can check each one to see. Oh wait, it says that's in the simplest radical form. Sorry. So this one's asking for simplest radical form. You need to make sure that anything that's underneath can't be broken down more. So if we look here, 50 you can break down into 5. 50 breaks down into 5 and 10.
You do 2.
And then 5 and 2. So that's not simplest, right?
You do 2 first.
Yeah, you could have done 2 and 25. That's true. So, this one I can't break down square root of x anymore. This one I can't break down square root of 2 anymore. And here 12 does break down. 2 and 6. 2 and 3. 3 and 1. We do have a group of 2 that comes out. So my answer choices would be these 2 simplest forms. So simplest means what's underneath the square root cannot be simplified anymore. Alright, questions on that? Yeah. Alright, so we're now going to that's where it is. Where was it?
Oh no, this one is up behind.
So why do you have it?
Nobody's name on it.
He's a nice guy for letting you borrow it. Alright, so let's take a look at our homework next.
Happy Wednesday.